Hi everyone, my team and I will be presenting on how we solve DECA assignment scenario 2 using linear programming. My team consists of Horace, Collis, Jade, and myself. The objective of this problem is to allocate the least number of officers working for each 8-hour shift. We have to find out the minimum number of officers the department has to allocate to work from 8 a.m. to 4 p.m., 12 noon to 8 p.m., 4 p.m. to 12 midnight, etc., etc. However, we have to meet this criteria. There is a minimum number of officers required to be on duty for different times of the day. From 8 a.m. to 12 noon, the minimum number of officers required to be on duty is 5. From 12 noon to 4 p.m., the minimum number of officers to be on duty is 6. From 4 p.m. to 8 p.m. is 10. From 8 p.m. to 12 midnight is 7, and etc. etc.
To solve the problem, we first let x1 be the officers beginning work at 8 a.m., x2 be the number of officers beginning work at 12 noon, x3 be the number of officers beginning work at 4 p.m., x4 be the number of officers beginning work at 8 p.m., x5 as 12 midnight, x6 as 4 a.m. x1 to x6 over here are the decision variables which we are trying to find out. How many officers to start work at 8 a.m., how many officers to start work at 12 noon, so on and so forth. At first, we must set the values over here to be empty initially, so we can be able to solve the minimum amount of officers needed. The objective is to find out the minimum of number of officers to be allocated to each timing while keeping the constraints. So we must make sure the officers are kept to the minimum so we won't waste any manpower or whatsoever. Hence, for our objective function over here, we take the sum of officers starting work on different timing, so to be set to minimum later in the solver. To find the minimum number of officers needed in total, just to solve all the constraints and make sure all the objective is met.
So we have 6 constraints in total, which are the minimum number of officers required to be on duty for different times of the day. So for the first constraint on the minimum number of officers required to be on duty from 8 a.m. to 12 noon, we take the sum of x1 and x6, which is the sum of the number of workers working from 8 a.m. to 4 p.m. as well as 4 a.m. to 12 noon respectively. Only they can make up the workers to be on duty from 8 a.m. to 12 noon. So we take this sum and we make sure that it is more than or equals to the minimum required, which is 5. From then on, we apply the same logic to the following 5 constraints. Next, we open solver and we set our objective cell to this cell, which has the formula of sum of officers starting work on different timings, and we set it to minimum. And then, for the by changing variable cells field, we set it to the values of x1 to x6.
After doing so, we inserted all 6 of our constraints inside the constraint field. We check the option that says, make unconstrained variables non-negative, because we are not allowed to have a negative number of officers working at a given time. Finally, we choose simplex LP as our solving method and press solve. As a result, a minimum of 19 officers are required overall. 3 officers should begin work at 8 a.m., 3 officers should begin work at 12 noon, 7 officers should begin work at 4 p.m., no officers should begin work at 8 p.m., 4 officers should begin work at 12 midnight, and 2 officers should begin work at 4 a.m. Thank you for listening to our presentation.